Once upon a time, a group of space explorers decided to embark on a journey to the largest planet in the solar system, Jupiter. They were fascinated by the planet's composition, hydrogen and helium, and were curious to learn more about it. As they approached Jupiter, they were amazed by its massive size. It weighed more than 2.5 times that of all other planets combined, but surprisingly had a mass less than 1/1000th of the Sun. The explorers were excited to learn that Jupiter's rapid rotation rate generated heat, making its interior warmer than the solar energy it receives. They observed a slight bulge around the equator, which gave Jupiter its oblate spheroid shape. As they ventured closer, they witnessed Jupiter's outer atmosphere with a series of latitudinal bands, which created turbulence and intense storms. The Great Red Spot, a massive storm that has been observed since 1831, caught their attention. Jupiter also had a planetary ring system and a powerful magnetosphere, the second largest structure in the solar system after the heliosphere. The explorers were surprised to discover that Jupiter had 95 known moons, including the 4 largest ones, Io, Europa, Ganymede, and Callisto, discovered by Galileo Galilei in 1610. The explorers' spacecraft had been equipped with technology to collect data and research Jupiter's atmosphere. They studied Jupiter's storms, its planetary ring system, and the magnetosphere before beginning their journey back to Earth. As they bid farewell to Jupiter and set off on their journey back home, they knew that their findings will help future generations of explorers better understand the mysteries of our solar system. Jupiter, the chief god of the divine pantheon, was a beloved figure in both ancient Greek and Roman civilizations. The planet Jupiter, named after him, has always been a source of fascination for humans, who have long sought to understand its mysteries. In 1976, the International Astronomical Union officially renamed the planet as Jupiter. Its many satellites have also been named after the god's descendants, favorites, and lovers, including Io, Europa, and Ganymede. The planetary symbol for Jupiter is derived from the Greek letter zeta with a horizontal stroke, which was an abbreviation for Zeus. This symbol has become synonymous with the planet and is widely recognized today. In Germanic mythology, Jupiter is equivalent to the god Thor. This connection gave rise to the use of Thursday, named after Thor, instead of the Latin name for the day, dies Iovi. The Latin name Jovis is also closely associated with the etymology of Zeus, and Jove is a poetic name that has been used since the 14th century. Many words and phrases related to Jupiter have entered the lexicon over time. For example, the adjective Jovian is often used to describe anything related to Jupiter, while the term jovial, among astrologers, refers to the influence of Jupiter on happy and cheerful moods. Even the word xenographic is derived from xeno-, which is rooted in the Greek deity Zeus. All of these details help to paint a fuller picture of the importance of Jupiter in human history and mythology. Once upon a time, in the vast expanse of space, Jupiter was born. Jupiter, the largest planet in the solar system, is believed to be the eldest planet. It began to form beyond the snow line, a region where water could condense into solids. Initially, Jupiter started as a solid core and gradually gained enough mass to collect its gaseous atmosphere. It had a composition of half silicates, ices, and other heavy element constituents, which made it unique. As Jupiter grew in size, reaching over 50 times that of the Earth, it created a gap in the solar nebula. It took over 3 to 4 million years for the planet to reach its final mass. During this time, the Grand Tack hypothesis suggests that Jupiter migrated inwards and then outwards. When it first formed, Jupiter was at a distance of $3.50 from the Sun Saturn, and its gas disk affected Jupiter's orbit, causing several super-Earths to collide destructively. Over 3 to 6 million years, Jupiter migrated outwards, allowing the creation of the inner planets, including Earth. However, the hypothesis of Jupiter migrating from the inner solar system predicts that Jupiter would have settled closer to the Sun, inconsistent with measurable elemental composition. Alternatives suggest Jupiter having an orbit close to its present-day properties or forming it at much farther distances, about 18 Australian dollars. Researchers suggest Jupiter's composition point to its initial formation outside the nitrogen snowline, possibly even beyond the argon snowline. In conclusion, Jupiter's unique composition and migration pathway have led researchers to many theories about its initial formation and its role in the creation of other planets in the solar system. Even with all the research done, many mysteries still surround the formation and migration of Jupiter, making it a fascinating planet to study and learn about. Once upon a time, a group of curious scientists embarked on a mission to study the composition of Jupiter, the largest planet in the solar system. Their mission was to explore the planet and collect data from its atmosphere. The scientists made a remarkable discovery, that Jupiter's atmosphere is composed of approximately 76% hydrogen and 24% helium by mass, with trace amounts of other elements like methane, water vapor, ammonia, and silicon-based compounds. They also discovered that its upper atmosphere is about 90% hydrogen and 10% helium by volume, and contains fractional amounts of various gases like carbon, neon, oxygen, phosphine, sulfur, and hydrogen sulfide. Even more intriguing, the outermost layer of the atmosphere had frozen crystals of ammonia, and hydrocarbons were found in trace amounts. What made this discovery even more fascinating was that the composition of Jupiter's atmosphere was similar to that of the theoretical composition of the primordial solar nebula. The scientists, therefore, concluded that this could provide insight into the formation and evolution of the solar system. As they continued their research, they discovered that Saturn had a composition similar to Jupiter. However, the other gas giants, Uranus and Neptune, had a relatively lower percentage of hydrogen and helium and a higher proportion of oxygen, carbon, nitrogen, and sulfur, making them referred to as the ice giants. This is owing to the fact that the majority of their volatile compounds are in solid form. Finally, the scientists discovered that the depletion of helium and neon in Jupiter's atmosphere was due to precipitation into helium-rich droplets occurring deep in the planet's interior. This made the study of Jupiter's atmosphere, and that of the other gas giants, even more exciting and intriguing for scientists globally.
Do you want to explore more Greek mythology stories? Who do you want to see featured next? Subscribe and leave a comment below to let me know. I'll see you in the next video.